Hello and welcome to this new Tyflow tutorial. Today we're gonna see how to break and reform an animated character made out of spheres. Traditionally, it's easy to reform a static and mesh in Tyflow, but when the mesh is deforming, it gets a lot trickier. I'll show you how to make it work. To do that, we're gonna use the Tyflow VDV toolset, targets, loops, and dynamic particles. This is a beginner to intermediate level tutorial. What you see on the screen is an advanced version of this tutorial that is available for sale. It has additional features like the character being reformed from bottom to top, which would be too long to cover in this tutorial. Remember that if you want to skip this tutorial altogether and get the finished file, you can get it from the link in the description. So let's see what we have in here. We have an animated mesh which is looped. This is important because we need perfect loops without weird artifacts within them, because the particles will be attached to this mesh, so the quality of the animation will affect the quality of the particle simulation. First of all, what we're going to do is work on the sphere packing, which is the process of filling this mesh with non-overlapping spheres. The way to do this is creating a Tyflow object. Let's open the editor. Let's move it to a more convenient location so that we can see the editor and the mesh at the same time. Now we're gonna use the Tyflow VDV toolset. In order to start using it, I'm gonna type Earth VDV, and you can see that immediately Tyflow is creating a VDV to mesh operator. That's because otherwise you wouldn't see anything once you add the mesh here. So let's hide the mesh. There's nothing here. That's to be expected. That's because we haven't imported the mesh into the VDV inside Tyflow. To do that, we're going to use object to SDF. And let's pick the mesh. And now you can see that Tyflow is creating a VDV, which is a bit low res. And the way to control the density and the quality of the VDV is by changing the voxel size. So if we change it from 1 to maybe half of it, you can see that the quality improves drastically. It's not that important for our example, but remember that that's the value you need to change in order to increase the quality. Let's change back to 1 for now. And now we're going to do an extra step here. We don't really need the mesh. We want the particles created inside this geometry. So the way to do this is creating VDV to particles. Nothing is happening here because VDV to particle is exporting to another event, and we don't have another event created now. So let's create one with a display, just a display. That means that whatever we send to the other event, it's just displayed and nothing else. So let's connect it. And now we can get rid of this VDV to mesh because we don't really need this mesh. And now I'm gonna create a shape operator. By default, it's creating a triangle. We're gonna use a geosphere low res. And even if Tyflow is set to VDV to particles, right now it's set to mesh to particles. But if we go down here, we will see this option, pack mesh with particles. So as soon as we do that, Tyflow will try to create these packed spheres configuration. And as you can see, no particle is interpenetrating with another particle. That's what we want. The way to control the number of particles is by going back to BearVDV and change the voxel size. Let's change it to 0.5, and now we are having a result closer to what we want. Take into account that there are a lot of another parameters you can change here. In VDV2Particles, you can change the maximum number of particles and the radius as well. So if you don't want the difference between the bigger spheres and the smaller ones to be so big, you can change it to something like 1 to 10 or 1 to 2 or 3. But let's keep it fairly big for now. Something like this. That's good. That's a good proportion. Wherever you feel that works for you in this case. Now, if we move the diamond, nothing happens, even if our mesh is still moving. So how do we attach continuously our newly created spheres to the mesh? So the way to do it is by using an object bind. The object bind operator will allow us to pick a geometry like our woman. Let's make sure the timing is set to continuous so that it updates every frame. And we don't want it to lock to object, we want it to lock to surface. The rest of values you can leave them as they are. So let's see what happens. That's good. At the moment it's binding, which is a way to say attaching the spheres to the mesh. Using also the rotation, we don't really need it, just the position. That's good. In order to see the spheres a bit better, I'm gonna create a material here and apply it to the spheres. You can see that we have this multi-material created here, which is just a bunch of standard materials. I'm gonna rename it to spheres. And I'm gonna select our Tyflow and assign it. And right now, it's only getting the color from the first shader. To get all the colors here, we're gonna use material ID operator. I'm gonna change this from static to random. And now we're gonna select the number of materials you want. In here, I'm gonna just select 1 from 9. I think that's more than enough for us. We can see all the materials assigned randomly from 1 to 9. Next thing is creating the system in which the particles fall down and go up. So Tyflow has the ability to set targets, and targets are just particles that are going to be acting as a kind of parents, so that the rest of the particles will go back to them. Usually you can just store the position in the first frame, then let the particles fall down, and they will remember where they came from, and they will go back. But that only works if the initial position doesn't change. In other words, if the original mesh is static. But now we have here an animated character. So the position, for example, let's say this is our reference particle, and then a particle goes down and bounces, and then it's time to go back. Then the particle is not there anymore because it's attached to the character, so it's moving. How do we tell Tyflow to go to this position that it's moving? Well, using targets. I'm going to show you how. First of all, I'm going to create a spawn operator here, which is going to create a copy of each particle here and place it in the same spot of the original particle. Okay, so now we have these spawn particles. And if you look at this number, we have 238 particles, and as soon as I click spawn, it's doubling it. That's because it's creating one particle per particle. Now I'm gonna send them to another event. I'm gonna create a display operator. Although the color here is purple, our particles are not showing this. That's because by default the display operator is showing the material. So as soon as I disable this, let's change this to another color so that it doesn't collide with the background. Now it's working. So what we want to do, we want to create a relationship between, for example, this particle, which is green, and this particle, which is the parent. We need some kind of connection between them. To do that, we're going to use an operator called setTarget. And here in the options, we're going to set it to from neighbors. There's a new rollout here that is available for us. And here I'm going to check exclude this event. So we only want the particles from this event. And now, how do we know if each particle has a target? Well, we can use display data. We're gonna disable birth ID, we don't really need it. And there's a handy option here called line to target. Let's see if it's creating a line. Yeah, well, you can see the line here. You can see there's something here saying line to target, cache non-available. That means that as soon as you move the timeline, Tyflow is not storing this information. We can force it to do it. We go to Tyflow, cache, and then custom float. We check that, see the message is no longer there. Now if we move, you can see the line. So now this is saying this is the parent, and this particle will try and get to its parent as soon as we tell him to do it. Okay, we know that this is working. Let's disable this display data. And now we want these set target operators to be active just one time. So set a target and that's it. Don't change your target. It's a one-time thing. So I'm gonna create a send out so that once the target is set, go to the next event. And now in the next event, I'm gonna use a physics shape. The physics shape is gonna turn these particles into a dynamic object. And Tyflow by default is creating a gravity and a ground collider. So let's see what's going on here. Let's press play. That's nice. We can hide the parents here, the targets here. I'm gonna rename these to targets and this one to dynamic particles. Okay, so if I disable this display, we are only seeing these particles. Okay. That's good. So what we want to do is make these particles go dynamic and then go to the original position, go dynamic, go to the original position in a loop. So they are forming the shape of the character and then going down and going up. That's the original idea. So I'm gonna set time test set to, for example, 20 and with no variation, so that all the particles are sent to the next event at the same time. So after that, I want the particles to go back to the original position. The way to do that is using a find target. Because remember, we've set a target here. So now we want to find that target here. Well, let's connect to this. Okay, so in the set target, you can see that the channel that it's using is just called target. Let's change this to something more custom. My underscore my target. Nice. And now here in find target, we can use this channel to drive our particles. So if we go to target location and we go to point, you can see there's an option called particle target. And as soon as you select this, this channel option is available. By default, it's 0, so now nothing will happen. But if we press this V, you can see that our channel created here is stored here. So let's select this. And there's a continually update option here that will allow us to our particles to follow the parents wherever they go. So it's going down until frame 20. And now you can see that it's starting to do something. I'm gonna disable real time. Okay, it's disabled. Let's make sure. And you can see they are trying to go, but they don't have enough strength because the gravity is too strong. So what I'm gonna do now is to increase this acceleration to something like 50, for example. Okay, it's going down, it's going up. And look at it. The particles are trying to get to their original position. Sometimes it's not possible because remember, this is a dynamic simulation and they are colliding between each one of them. So they will try their best to do that. The strongest the acceleration, the most likely the particle will reach the destination. So now let's go and create this loop. And to do that, we're going to use a simple time test. And then it depends on the effect you have in mind. But of course, you need to leave enough time so that particles can create the effect of the particle of the character walking. If it's too fast, you won't have time to see anything here. Let's try and connect this with this. And I'm gonna right click at point so that the line is not crossing. So now basically we've created a loop here. So after 10 frames, it will go back to this event, which is the physics. And after 20, we'll go here and again and again. So let's see what happens with just 10 frames. Okay, so the particles don't have enough time to fully form the character, so they just go down. Let's increase this to something like 80. Okay, so we can see that the general setup is working. But we can see now that the particles are a bit springy. Instead of going to their place and stay there, they just bounce up and down. If you don't want this, maybe you want this, so that's okay. But if you don't want this, you need to use a flow operator, which is Tyflow friction. And I'm going to use a fairly high value, like 40. Now, yeah, I think it's better, but it depends on what you are after. Okay, so that's good. I think we have the general thing working. Of course, if you want the particles to go slower or whatever you want, you need to play with the forces here. But I would like to do a final thing here. And as you can see, we don't have these particles walking at the beginning of the video. So I would like it to walk for a few frames and then fall down. So what I want to do here is in these particles, I'm gonna change this send out, which is an instant process, so that once they come to this event, they are sent out to the other. I don't want this. I'm going to use a time test. And I'm going to use, I don't know, something like 50 frames. And I'm going to use a link to target. So now, I'll link to target, and I need to change this channel to my target. So now they will walk with the character. And now here I'm gonna copy this and I'm gonna set it to unlink. And now it should work. Yes, it works. And now it enters the loop and it cannot escape the loop. And they go down and they go up again. That's as long as you want. We can do is to set this to display material so that it doesn't change. And that's all for this tutorial. I hope it helps.